Hello, everybody. Welcome to our weekly show, The Routing Loop, where we talk about all things networking, edge security, network security. Today, we've got a session for you on edge security, and I have my colleague with me, Itaf. So my name is Tom. If you haven't seen the show before, I'm one of the moderators. Sometimes I also present some sessions. So our guest today is Itaf. I'll let him introduce himself and tell us about what he's going to cover today. Itaf, over to you.
Thank you, Tom. Thank you for having me. Hi, folks. I'm Itav. Itav Aditi. I'm an edge security specialist, a solution architect within AWS, working primarily on CloudFront, WAF, Shield, firewall managers, and all the stitching between all those together. So great to be here. Today, I'm very glad to talk about one of those features that goes below the radar, and to hear your opinions about what is useful for, what is not, and how we might be getting even better. So happy to discuss about it with you.
Whereabouts are you based? So we always like to hear from folks that are joining on the chat, but where are you based, Itaf?
Recently I moved to New York in the last couple of months. Before that, I came from the Cyber Nation, Israel, where I worked with a couple of startups and AWS there. And here in New York, I'm working with a lot of security partners to increase this ecosystem security within AWS.
Nice. And as an edge security specialist, you work mostly on protecting the perimeter for customers. Is that right?
So the official definition, yes, but I would like to look at it on different paths. So I want to reduce the headache from customers and companies so they can deliver the application while we take care of the rest. So it could be delivery, it could be authentication, it could be perimeter security, whatever that I don't the customer to actually handle. Because no one woke up in the morning say, I want to connect a VPC. They want to build their own application. So I do the stitching for them.
Awesome. And I feel like every time we have folks that are like, I'm assuming your background was web development as well, front end development, or you were always in like deep security side.
So the majority of my career was web development and engineering in general. I add into security because I've seen so many security aspect in my previous role that was emerging into my application levels, and I just wanted to know better and not just my CISO yelling at me what I need to do. And this is where I added to security aspects.
Nice. And I think that's going to show in your presentation as well, because we have some demos, we have a presentation, but it's yeah, I'm just going to pop it up here. We
Thank
can
you.
expect some flashy visuals as always.
Yeah, hopefully it will be flashy enough. Nowadays, everyone are creating so crazy flashes using AI, so hopefully it will stand with the bar. But yeah, just give me a reason to build something, and I will build it. So this time I built this. So I call this session Behind Block, and this is how we can turn AWS Web Application Firewall into more of a control plane before your actual application. So Web Application Firewall was built in order to create both built-in and customization over layer 7 protection. You can think about it as the guardrail before the traffic is arriving to your own application. So we will see mostly Web Application Firewall are being associated with your ingress layer, which is CloudFront, API Gateway, ALB, AppSync, Incognito, or whatsoever on the ingress layer. And this in order to filter out unwanted traffic. And unwanted traffic could be from the cyber aspect of the world, someone tried to hijack your system, or also from the fraud aspect of the world. If you see a certain player doing X amount of requests, doing Y amount of time, you not necessarily want to serve traffic. But in the last couple of years, and necessarily in the last couple of months, we see it expanding. So we don't just want to block traffic. We want to serve different traffic to those different rules or different players. And we're going to discuss today about the feature that's allow you to do it in a scalable manner.
Perfect. So I guess for WAF, we think about WAF anytime we have an external facing surface that's web-based, right? If we have a HTTPS application that's facing anywhere to the internet and hosted on CloudFront, ALB, API gateway, I can just enable WAF. Do you mind sharing a little bit for folks that maybe haven't seen it, how easy it is to integrate? Is that something that, do I have to put something in the path, or is it just pretty much a single click of a button and it magically appears on my solution?
Yeah, so this is a good question. So I will go quickly to show how easy to doing it using the AWS console. So here in my example, I have the CloudFront console and I have the security aspect. So if I go into security and click on manage protections, if I don't have any protection in place, I can just click and enable it. And if I do have protection, as in this case, I can look and see the different protection that I have in place. So yes, in a click of a button, you can enable or disable it. And once you go a deep diver into it, you can also customize the different rules that you want to protect against.
Perfect.
Cool. So Tom mentioned about the request is eating your ingress layer, your port 80 or 443. So the second that's the moment that sees it, the ingress, and you have WAF associated with it, we are scanning the request using WebACL. And we are doing it in a priority manner. It's like a waterfall of rules of if-else. So if some request eats a certain rule, it won't eat the sequence one. And for every rule that we got matched upon, we will emit a label. So in this example, we have a rule of part of our bot control that was it a scraping. We detected it as a scraping. Or maybe you have your own custom rule that you identify this traffic as an enterprise customer. And what you can do with those labels basically is create an action. And action is one of couple actions. So the straightforward is block. So if I have a scraper, I want to block this traffic. Moreover, we can count. So I don't want to block. I just want to understand how many hit I had on those labels. Moreover, I can do challenges like JavaScript challenge or a CAPTCHA to have a better verification of the traffic. And last, I can allow. So for example, no matter what scraper eats my WebACL, for some reason, I want to allow it. So this is additional option. And between those actions, we have some customization. So the first customization is a custom response. So for example, I block a traffic. And if instead just of giving an error code like 400 or 500, I want to give an HTML back that explains what was the issue, or maybe a JSON back, depends on my client. And the same goes on the request. So if we are doing an allow action or a count action, and I want my origins, for example, my EC2s, my Nginx, to whatever origin that I have after the WebACL, I want it to understand what labels the WAF have matched. So we can create a custom request header where we can inject those X headers. So our origin can observe it and react differently or just log it. So this is, I said 60 seconds, it was more of the 120-second brief on WAF.
Yeah. So I guess like WAF is doing all the heavy lifting, right? To do the analysis, figure out what's actually coming your way, and this gives us the ability to, once we apply the labels, make use out of that information in an easy fashion.
Yes, correct.
Nice.
Yeah. And we allow this granularity. So you can think about all the custom rules that you're putting in the wild. So here, just an example. of the tiering or the audiences or the gear or the risk, each one of those rules will emit a label. So we counting here more than 10 different labels that you can customly emit. And if you will use the Amazon managed rules, which are a dedicated rule for certain different exploits, each one of those rules emit more labels. So we're in the era of a couple of dozens labels in WAF. And if you will use bot control, up until February this year, February 2026, we emitted more than 200 different labels of the different bots and agents around the globe. But from February, we increased the amount of bots that we detect using WAF. And currently, it is more than 650 different bots and agents. And this number will just increase over time because we all know agents is all over the place. So counting it all together, we're talking about hundreds of different labels that are currently part of your web ACL, your WAF configuration, that you need to react into it. So while it started as a very granular, custom-made solution, it inflated into something that we need to understand how we manage it into in scale. So no matter how many bots we'll detect in the future, the same amount of rules, the same amount of custom mitigation that you've put in place, we can work with it.
So in that slide, on the left-hand side are the labels that you can generate yourself or create yourself. These are just some suggestions, right, that you're showing here.
Yeah, those are some suggestions. Any kind of custom business that you want to put in WAF can be done here. Those are the suggestions that we see most of the customer that using custom rules are applying, but it highly depends on the customer business logic.
But I could add my own label in there saying Tom's label and apply it to anything I detect. If it comes from a specific IP address with a particular header, add a Tom label on top of that traffic, and then that request is labeled. And then I can decide if it continues with the analysis, and maybe I have another evaluation that looks at that label and some other parameter, and maybe I look at the labels that AWS will automatically add. Is that kind of how customers would typically use it?
Yeah, exactly. So most of the customers will start with the managed rules of the world to get them secured out and fast. And after they start to analyze the traffic and they understand, okay, I want to apply very specific rules because my application only should serve 100 people in a couple of minutes, they will start to apply those custom rules.
Okay, because there's some questions from Lewis here. I'm going to pop one here. Kind of how do customers use the WAF labels? I guess ultimately I feel like the question is like why do organizations care about getting the labels? And I think that kind of leads towards the bot control and agentic workloads.
Yeah.
Why do customers want to pass the traffic and then label it rather than take the action on the edge?
Yeah, this is a good one. We need to first understand that WAF was built to do security at its best, meaning we can detect a very significant amount of those malicious traffic. But if you would like to do some kind of serve a different kind of data to those agents or malicious traffic, you still need to process it in a deeper layer, which can be CloudFront function or Lambda at edge or the ALB or your origin. Using those custom labels and the features that I'm going to present very soon in 2 slides, you can give those insights into your origin, meaning if this is a legitimate user or if it's a user that's WAF marked as not legitimate or suspicious user. And then your origin can have the control of what kind of traffic, what kind of response to serve. One of the actual demos will present just this use case. So, and we'll also share example code that you can start using it in an hour from now.
Perfect.
Cool. So when we thought about how we can address this population of so many labels, we started to think about creating our own language. And Honestly, this could not scale because inventing a whole new language nowadays, meaning that agents will need to learn it. So we kept to the basic and to try to understand how the entire internet and the entire engineering ecosystem is handling with static string. And what we found out that both JavaScript, Python, and probably any other language already have those solutions. So we can have a very dynamic value, like an IP, and create those templates of string and inject the IP within the string. The same, similar goes with Python. So what if we can do the same using WAF to take all those dynamic values and more than hundreds of different values that we have there and have customers inject them within WAF. And basically, we ended up something very similar to what we already know from JavaScript and Python. You can now use dynamic labels. This is the name of the feature within WAF, both on the response headers, response body, and request headers. So this is an example of a very dynamic value, like an AP, but this is valid for any kind of label that you have in the system.
So does it mean there's like a predefined set of some dynamic values that we have, as well as the labels that you apply yourself, or labels that AWS applies?
Yeah, in the next slide we will see all the predefined labels and all the custom that you can put.
Sorry, stealing your thunder.
No, this is good. This is just signal me that the slides were made correctly. So a bit about the nuance, because there must be some nuance. So if we have a single value of the category, it will just resolve to a single string. But what if we have a couple of values? For this example, we have bot control analyzing two different signals. This is where the dynamic labels will resolve into a string list with comma as a separator. So this example, we have automated browser and non-browser user agent as a signal. And what if we use the syntactic values? So we will just have always the string that's resolved of the syntactic values. We will see in a slide all the syntactic values that we have. And if we don't have a match, we don't drop the value, we apply an empty string. And this is something that you should be aware of. So if you're creating your application based on dynamic labels of WAF, you should be accept to get not undefined, but an empty string if you don't find it. So where we can apply those dynamic labels. So if the action is allow count, meaning the request will flow into the origin, we can apply it on the request header, which is a custom request header. And on action like block, we can apply it on the response body, as I mentioned, HTML or JSONs, but also on the response header, meaning we can now override the location header, for example, to do a dynamic redirect for our customers. And I want to go here quickly. So what kind of dynamic labels we have? We have the synthetic ones, currently supporting those four. The user IP, the unique request ID, and the JAF fingerprint, which is the TLS termination fingerprint that's WAF calculated. Also, all the managed labels are can be auto-used by the dynamic labels. And as we mentioned, all custom labels that you defined using the AWS console or using your IAC can also be consumed as a label. I will stop here for a second, Tom, because you asked about it.
Yeah.
So
how do you see customers? If you have a slide on it, you can tell me so. But how do you see customers using some of these? Right. So let's say the IP address or request ID or JAR3, JAR4. Is it more common to use that in the response back to the whoever's connecting and they got denied, or is it more common to pass it to the origin? Because I can imagine for like the bot labels, I think that's super useful to pass to the origin, because some of the
Yeah,
decision making on, AWS WAF detected that this is a potential bot. It's giving you some information about it, but it's maybe too hard at this point to say, do I really want to block it or not? And that might be your
correct.
application layer decision, right? So your application owners might use that information and say, okay, it's a bot, but also I have some other info in the request and I understand now from a business point of view. So that's adding a lot of value. But I'm curious how those synthetic metrics are used from customers' point of view.
Yeah, so as always, it depends. So I've seen different of use cases. So for the synthetic ones, I've seen and we have demo to showcase very quickly how to use the IP and the request ID as part of the response. Meaning you're blocking the traffic and you want the human behind the scene that's got blocked to be able to reach out to your support and tell your support, okay, this is my IP and this is the request ID. Please help me out understand why I was blocked. We all probably saw those kind of HTMLs behind the scenes. So nowadays it's managed using WAF. For the JAF fingerprint, this is more of something that I would consume back to my origin, because this is a very significant signal about the traffic. So TLS fingerprinting is very highly valuable for fraud detection. So if I have any kind of machine learning algorithm or any kind of detection of malicious traffic that I'm doing on my backends, I want those JAF fingerprints to be available on my backends, the same as connection IP is, honestly. And for the managed rules, I would say that all the examples that I've seen so far are on the origin side. No one want to expose in the response the managed detection, because this is basically giving away why a persona was blocked. And for the custom rules, it was very creative. So I see customer that's generating a different HTML for their customers depending on their tier. So a premium tier will get an HTML with a premium email how to contact the support, and they get certain SLA. So in the custom, the sky is the limit. So I'm sure that AWS customers will be very creative on how to use those.
It's interesting. So the tiering is very interesting, because that sounds like they're using, exactly as you say, like kind of your title of the session, right? It becomes a control plane. WAF starts doing some analysis to understand the customer tier and then passes that information to the backend. And then you're
Uh,
using that to adjust the behavior of the origin, right? So that's very interesting.
yeah, I'm glad that you found it out, because you shared about my background, which is from the engineering point of view. So if you would look at WAF, and I really simplified what WAF is doing, but WAF is a very scalable way to do if-else statement. And this is the very basic engineering part that you can do. So if you can look at what WAF can do if-else statements and the context of the information that WAF have, you can find a very creative way to create custom responses directly from the WAF. And we see more and more customers trying to move some of their business logic, of a very thin layer of their business logic that usually was part of their first or second middleware within their application, into WAF or CloudFront functions.
Okay, super interesting. There's
Yeah.
another comment here. Like if you go back for a second, probably a clarification. Like these three source options here, you can pick and choose, right? You can use all three at the same time. You're not forced to just
Yes.
decide, hey, I'm going to use just synthetic. These are just options for the values that you can decide to pass on either to the backend or in the response to your client.
Exactly, Tom. So yeah, you can pick and choose how many labels that you want to use. We do have a limit of up to 10 labels within a specific string. So if, for example, you're bringing a custom HTML, so you can use up to 10 labels, custom labels within it. But if you're just using it among different rules, you can use whatever you would like, both synthetic, managed, and custom. And you don't need to pre-declare what you're going to use. You simply use those curly brackets within your string, and then we know that we need to translate it for you.
Cool. Very cool.
Cool. So let's go into the demo and cross your finger that everything goes well, because this is an actually live demo. Okay. So I'm starting from the easiest, simplest implementation into the more advanced that we see customers that are using it for the last couple of weeks and what they came up with. Let me zoom in. Okay. So here I have a simple demo. That's all it goes and doing is blocking my traffic. Very simple. 403 traffic that is being blocked. Nothing fancy in it. So this is what you usually would see when you're blocking traffic using WAF. Let's see together how we can use. Sorry, let me log in quickly. Okay.
So we're gonna customize that blog page, right?
Yeah, so this is the WAF console, if you are not aware of. So in the left side, I have a couple of web ACLs, meaning different configuration of WAF. So we're going to have 4 different demos, so I prepared 4 different web ACLs ahead. In the right side, I'm going to manage the current rules. So here I have a basic 2 rules. And as I mentioned, WAF is basically an if-else statement. So I have an if statement that's if the URI path is block-page. I'm going to, is block-page, and I'm going to check the accept header. And if this client is accepting HTMLs, I'm going to respond with an HTML. So currently, I only use 403 as an HTTP status code. But I can also use,
You might want to make that window a little bit better if you can scroll expand it.
Thank you. So I can also check one of my prepared HTML. So I'm going to choose the static HTML and deploy it, and then we're going to actually see the code behind this HTML because the deployment can take a couple of seconds. So I'm going to save it, and let's see the HTML here. So a very plain HTML, some CSS that I created or Kiro created for me. And in the div here, I've used a dynamic label, the synthetic dynamic labels of the IEP and of the request ID. So now I have a very custom HTML for my customer that if they're eating a 403 for some reason, they can reach out to the support and use those data. So let's see if it was populated already. Cool, and it was. So instead of just 403, now I have my IP. Please don't DDoS my residential IP. And I have the request ID, which is unique per request. So this is one, but it doesn't go just like that because we can also do it with JSONs. So as I mentioned, as an if-else statement within WAF, I can check the accept header. And if this is an JSON, now I can do a custom response for JSON. So I prepared ahead a dynamic JSON, which we can actually see it here. Quite straightforward JSON. We have an error, we have a context, and we are responding with the dynamic labels here. I'm going to save the rule.
We're crafting the blog page, and but we're including dynamic information in the response, right? Because that IP address and the request ID are going to be unique to your request.
Yes, correct.
Kudos, by the way, for V6 in there. I think Alex would be really proud of you. It's one of our other moderators that she likes V6.
Yeah, thanks to my ISP provider for my V6 here. Okay, so I created a render is so we can see the different blocking. So in the left render, I'm sending the accept HTML, so I can see I have the custom HTML, and if the rule was propagated correctly, and it was. Now, if I'm sending the application JSON, I can get a very customized JSON rule. So it's the same endpoint, the same WebACL. All I done is two rules, one for HTMLs and one for JSONs, and structure those dynamic labels into it. And this is the simplest example that we can showcase. I'm sure that the customer are much more creative to build their own very fancy HTMLs and JSONs out there, and even integrate additional data into it.
Nice.
Yeah. So this was the custom response body. Now let's talk about the custom response header. So instead of just replacing the body, the payload body of the response, we can also override some of the headers. So I'm going to navigate to the live demo. It will be easier to do it. So I automatically got redirected, and someone verified that my redirection is correct. So this was done quite quickly, which is great because this is WAF is doing it behind the scenes. But now let's do step by step to see what happened in those milliseconds. So when I send a verify request, WAF, instead of blocking the traffic, responded with HTTP 302. The HTTP 302 also contained a location header, navigating me to a different URL. This could be my internal system, maybe some other team that's doing verification for me, or this could be a third-party vendor that I'm working with that can validate my traffic. Within this location header, I also incorporated the IP address and the request ID. But again, this could be any kind of labels that you have. So this could be also your own custom rules, like the tier or the geo of what you understand from the user. And then we have and I will run it once again. On the right side, I have my mocked vendor validating the information that was sent via the URL and the headers. So all of done quite quickly, and we will go to see how it's happening in the WAF console.
This is neat. So this is ultimately kind of a dynamic redirect that you update on the fly with specific information of the request.
Yeah.
What would be the use case for that validation? So it's like you're connecting to a vendor, they require some information about your request, about your IP, or about some label that's coming in, and that could be used and that could be passed on to that second endpoint that you've hit.
Yeah, so this was the most simplified way to do verification. But think about, for example, for queuing mechanism, where a customer need to come with a cookie that's waiting in the queue of my website. And if I don't find the queue, I can redirect it into the queue provider with my current information that I have on this customer. And then my queue provider can check the IP and the request ID or whatever information that I have on the request to validate if the user was already part of the queue. And if it was, this user doesn't need to wait any longer. The provider will insert the cookie for it and then redirect back to my website. So this is from the verification, but this is also be from your internal system. So if you have different microservices and one microservices only can respond for some reason with JSONs, let's say, if we're taking our previous example. And if you need to render an HTML, you can do these custom redirects to the other microservice that do the HTMLs. So whatever information that your current origin is observing, you can think how to expose it as part of those custom headers. And I've used the location for redirect because this is rendered nicely, but this can be any kind of custom header, not just location. So let's see the rule. So I have the first if statement for /verify. which I created a custom response, which is 302, because I want to do redirect. And here I defined the response header, which is the location response header. But again, this could be X, my custom header, if needed. And within the value, I use my custom dynamic labels. Sorry, my syntactic dynamic labels.
Mm-hmm.
And that's all I needed to do in order to create those dynamics redirects. Okay, and for the third demo, how we can incorporate dynamic labels within custom request header. Basically, how we can send signals back to our origins about what WAF found within the request. So I created this demo, and I just pick and choose different user agent of the globe that could be some sort of bots. And I'm going to run classification. It's going to run, and everything is working, right? So I have my origin that understands the category of the HTTP library and the bot name, which is CURL. The same goes with Python, GPT, Claude, or Slack, and whatever other bots that I wanted to signal back to my origin. So this is doable, and this was doable with WAF since custom request headers was invented a couple of years ago. But when we see the era of increasing labels, specifically bot labels, and as I mentioned, bot control is now detecting more than 650 different bots, it required some heavy lifting on the operation side. So let's see what required for me in order to define those rules. I'm going to zoom in a bit. So the first rule that I have is the bot control. And this is the default bot control when I change all the action instead of blocking to count, because I no longer want to block the traffic. I want to count it and use those information for my origin. But after the single bot control, the default bot control, I need to create rule for each one of the bots. For example, for the CURL, I need to create an if statement. So if the name is CURL, I need to create custom headers. I'm going to zoom out for a second. I need to create custom headers and inject those values statically. So now I know this is an HTTP library and a CURL. And this goes for all the rest as well. For example, for Python. So I need to create an if statement. So if the bot name is Python request, I need to inject a new header with the HTTP library as the category and the Python request as the name. And you probably guessed it correct. This goes with the GPT, Claude, and Slack. So if I want to cover all the 650 different bots of the world, I needed at least 650 rules in it. And this does not count the custom rules and the syntactics. So using the dynamic labels, we can inject those in a single rule. So I'm going to actually remove. I will do it as quickly
what
as
I've seen
possible.
some customers try to do to work around this, because this means ultimately that any information, you ultimately can only pass one header in the old days prior to this feature launching, right? So for every rule, you can pass one header. So what I've seen customers do is try and acquire a bunch of labels from different rules, then have a kind of final rule that looks at multiple labels and tries to then kind of create this amalgamated header that they can forward to the backend, but it becomes so complicated to manage to be able to like tackle all of the changing environments and the constantly new added bots, bot detections that we're doing.
Exactly. So this was required you to keep up with the different bots of the world. And as we, as AWS, are putting more bots out there, you needed to put more rules and labels out there.
Putting more bot detections out there, right? We're not putting
yeah,
more
exactly. Yeah, so sorry. Yeah, more detection rules out there. So now I switch to only one rule, and this rule is using the custom, the managed dynamic labels. So here I'm injecting the bot name and here the bot category, and I don't care, it could be the HTTP library that we saw before, or scraper, or hosting provider, whatever that AWS was detecting. Same goes with name, signal, and the client IP, just for fun, because we love those IPs. I'm going to save it, and we need to wait a couple of seconds until it propagated. But as you can see, I removed currently 5 different rules that I needed to use before, and now I have only 1.
Yeah, 5. There were 5 because you decided to pick on these 5. But if you wanted to do all the potential bot combinations we have, you'd need 650 rules, which wouldn't fit into a web ACL.
I would need 650, and I need engineer on a weekly basis to check if there are new bots out there and update those. Yeah. Okay. So it was propagated, and as you can see, the values now, let me zoom out a bit, are being automatically pulled from the dynamic labels. So if I don't have a value, this is the empty. As I mentioned, we do have empty string if we don't have a signal. And here is an example where we did add all the values inserted, including the multi-value. So we understand this traffic is coming from AWS. Yes, I'm using the AWS VPN at the moment. And yes, I'm not using a user agent, a browser user agent. So we inserted all those values with a comma. Yeah, so this works. And how we can incorporate even further, and I will do it very quickly because some of the audience ask how we can do custom responses, right? So now when I can inject those custom headers to my origin, I can build custom responses. So on the left side, I'm sending a legitimate browser. I'm responding with an HTML. But if I'm an agent, maybe I want to respond with, you guessed correctly, with a Markdown, because Markdown are the new HTMLs of the world, which is great because now my origin know what kind of agent is it and what kind of response to send. But if you see it correctly, now all my cache are missed because I created a very dynamic values. This doesn't necessarily need to stay like that. And why so? Because CloudFront cache policies can actually observe the custom headers that we put. So I'm quite quickly moving to CloudFront, and using the cache policy instead of disable, I'm going to use a custom policy that I've created. I'm going to deploy it, and we will see it quickly.
So now we're changing. It's no longer WAF. We're in the CloudFront configuration, modifying the cache settings and cache behaviors for that CloudFront distribution that you have your WAF deployed on.
Yes, correct. So what we're seeing here is CloudFront as a caching mechanism can now read the headers, the custom headers that we injected using the dynamic labels, and we can define how caching policies work with it. So I created this caching policy, and now I'm caching according to this custom header. So if my WAF dynamic value was crawler or an agent, this will be cached with a certain value. And if it was injected with legitimate browser and my origin responded with HTML, now the caching policies will responding differently. And of course, we can do it among different headers and among different query string and create these metrics of all together.
I guess you want to be careful to pick the headers that don't have too many variability, too many options in the values, right? Because then you're going to have too many different cache keys.
You are completely correct about it. I would say that I first want to understand my origin, my application. So to understand to what extent of values I do respond with a different value, with a different HTML, with a different JSON, with a different response. And once I understand my application layer, now I can create my caching policies thanks to that. So yeah, you are completely correct. I would not use all the headers and the values out of the word. I would use only the headers and the values that my application is actually responding differently according to.
Or would it be dependent on the kind of content I want to return? Because in reality, you have two different types of content here, just HTML and the Markdown. So ideally, we
Correct.
want to have some kind of binary, like it's either I need to cache Markdown or I need to cache HTML, because whoever's consuming it is either a human or a non-human, I guess.
Correct. So we can see now that it was deployed. That's my browser is getting HTML, and it was it from the cache, and my mocked agent is getting Markdown, and it's also it from CloudFront. So my origins no longer need to walk for those traffic, and I do manage to respond differently to a different kind of customers, thanks to my WAF as the control plane deciding it for me.
Yeah, I like your comparison of like an if-then evaluator that you have at the edge that then you can use to make decisions.
Yeah, this is how I simplify it to myself. This because honestly, this become too deep for everyone. So we need to simplify everything for ourselves.
Yeah, I like that.
So to recap quite quickly to what we've seen here. So when a request from a viewer eating your origins, so if you're using CloudFront and WAF, it will first eat CloudFront. Before the actual cache, we will have the WAF. The WAF can use those dynamic labels in order to A, respond differently, or B, inject a custom header. When you're using a custom header, you can also have CloudFront function, for example, using those custom headers to create some of custom logic. And then you have the CloudFront cache that can, as we see, have a different cache according to those headers. And lastly, you have your origins. So this gives you a lot of little middlewares that you can take decision and reduce the load and the risk from your origin if it's viable. Before we are ending, these are two GitHub repositories that you can start working with today. So the dynamic labels showcase all the different examples that we see today in the live demo. And the automated Markdown, this is a quite neat sample that you can apply on CloudFront and WAF. And basically, it converts asynchronously all your HTMLs into Markdowns, and only if your agent is accepting Markdowns. So it doesn't go to your S3 and just convert everything. It converted on a lazy basis only if needed, and it uses the dynamic labels as well. So you can check the QRs, and it will sit within AWS-samples GitHub repositories.
Awesome. Very cool. All right. Ita, thanks so much.
Yeah.
So we had a few questions. I think we tried to tackle them. There's some question from Lewis, which I think we touched on mostly. Yeah, I agree with Hiverings. This is a great demo. It's always nice to see good visuals and having it like nicely structured and easy to follow. So thanks for that, Ita. Yeah, I think with that, we can start slowly closing off. If there's any additional questions, folks can pop them in the chat. Otherwise, you can probably try and find us directly or through your account teams. You can pull an Ita for myself. Ita, thanks a lot for jumping on and sharing the demos with us and pulling the content together. This was really great. Yeah, thanks everybody, and join us next week.